Good day, everyone. I am here to discuss to you the security best practices for big data solutions with the title of Google. So, first practices is safeguard distributed programming frameworks. Distributed programming frameworks such as Hadoop make up a huge part of modern big data distributions, but they come with serious risk of data leakage. They also come with what's called untrusted mappers, or data from multiple sources that may produce error-ridden aggregated results. Next is secure your non-relational data. Non-relational databases such as NoSQL are common, but they're vulnerable to attacks such as NoSQL injection. The CSA lists a bevy of countermeasures to protect against this. Start by encrypting or hashing passwords, and be sure to ensure end-to-end encryption by encrypting data and rest using algorithms such as Advanced Encryption Standard or AES, RSA, and Secure Hash Algorithm 2 or SHA-256. Transport Layer Security TLS and Secure Sockets Layer SSL encryption are useful as well. Next practices is secure data storage and transaction logs. Storage management is a key part of the big data security equation. The CSA recommends using signed message that digests to provide a digital identifier for each digital file or document, and to use a technique called Secure and Untrusted Data Repository or SUNDR to detect unauthorized file modifications by malicious server agents. The handbook lists of a number of other techniques as well, including lazy revocation and key rotation, broadcast and policy-based encryption schemes, and digital rights management or DRM. However, there's no substitute for simply building your own secure cloud storage on top of existing infrastructure. Next practices is the endpoint filtering and validation. Endpoint security is paramount, and your organization can start by using trusted certificates, doing resource testing, and connecting only trusted devices to your network by using a mobile device management or MDM solution. On top of antivirus and malware protection software. From there, you can use statistical similarity detection techniques and outlier detection techniques to filter malicious inputs while guarding against civil attacks. Example, one entity masquerading as multiple identities and ID spoofing attacks. Another practices is the real-time compliance and security monitoring. Compliance is always a headache for enterprises, and even more so when you're dealing with a constant deluge of data. It's best to tackle it head on with real-time analytics and security at every level of the stack. The CSA recommends that organizations apply big data analytics by using tools such as Kerberos, Secure Shell or SSH, and Internet Protocols Security or IPsec to get a handle on real-time data. Once you're doing that, you can mine logging events, deploy front-end security systems such as routers and application-level firewalls, and begin implementing security controls throughout the stack at the cloud, cluster, and application levels. The CSA also cautions enterprises to be wary of evasion attacks trying to circumvent your big data infrastructure and what's called data poisoning attacks. Example, falsified data that tricks your monitoring system. Another practices is Oh, preventing data from unauthorized access is a cause of concern for the data scientists. From across the globe, it's a big challenge to protect the integrity of data as it moves through different stages of analysis, input processing, and output. Existing data security solutions may not be enough to safeguard a big data environment, making the task even more challenging. While it is practically impossible to build a foolproof big data system, there are certain preventive measures which can effectively alleviate data breaches to a great deal. Following a set of best practices can be the most logical tactic to mitigate potential security risks to your big data implementation. So that is all the best practices for security solutions. That's all. Thank you.